Dear student, good morning. Now, today we will start our next topic, and that is graphical representation of motion. So, today we will discuss different kind of graphs. We will talk about distance time graph, displacement time graph, and from there we will talk about the uniform and non-uniform motion, and we will discuss about certain quantities which can be found from these graphs. So first of all, I'll start with distance time graph. So here this is your y-axis and this is your x-axis. On x-axis I'll take time, so this is time axis, and this is your distance axis. So let us take the different time intervals as 1 second, 2 second, 3 second, 4 second, 5 second, and so on. So time is in seconds, and distance I am taking in meters. So let it be division be 2 meter. So we are taking the distance as in the divisions as 2 meter, then 4 meter, then 6 meter, then 8 meter, 10 meter, and so on. And let us suppose our graph is showing a straight line like this. It means that at 1 second the distance of the object from you is 6 meter. On 2 seconds it is again 6 meter. On 3 seconds it is again 6 meter. On 4 seconds it is again 6 meter. So what is happening here? Time is changing. Time has started from 0, and then 1 second, 2 second, 3 second, 4 second. So time is changing, but the distance is of the object is same every time. So distance is not changing. It means that the object is not moving at all. It is at the same position. Once again, it is only at 6 meters from you. It is lying at 6 meters. Time is going on, but the distance of the object remains constant. So it means that the object is at rest. So whenever we get any distance time graph, okay, and it is of such a shape, it means that here we are taking distance axis and time axis. If you are getting graph in this way, where distance time graph is parallel to time axis, then the object is at rest. Now I am taking second graph. So again, this is your distance axis. Distance is in meter, and this is your time axis. Time is in seconds. I am again taking it to be time as 1 second, 2 second, 3 second, 4 second, 5 seconds, and so on. And distance as 2 meter, 4 meter, 6 meter, and so on. Now see, suppose if I am getting a graph that is a straight line with some slope to time axis, it means that as the time is changing, if the time is 1 second, at this the distance is 2 meter. When time is 2 second, the distance traveled is 4 meter. When the time is 3 second, the distance traveled is 6 meter, and so on. So what is happening in first second, 1 second, the distance, if I am taking time here, distance here, in first second the distance traveled is 2 meter. Then in 2 seconds the distance traveled is 4 meter. So at 2 seconds distance traveled is 4 meter. In 3 seconds the distance traveled is 6 meter. When time is 3 seconds, the distance traveled is 6 meter. Now see what is happening. In 1 second it has traveled a distance of 2 meter. In next 1 second, this time gap is of 1 second, 1 to 2 second, it is 1 second. In 1 second, again, how much is the distance traveled? Object has started from 2 meter and it goes up to 4 meter. So the distance traveled is from 2 to 4. So how much it is? 3, 4. It means 2 meter. In next 1 second, the distance traveled is 2 meter. So in first second, the distance traveled is 2 meter. In next 1 second, the distance traveled is again 2 meter. In next 1 second, the distance traveled is 1 meter. So in every 1 second, the distance, every time distance is traveling 2 meter, it means that object is moving with uniform speed, or object is moving uniformly. Every time in 1 second, the object moves a distance of 2 meter. So if we are getting any graph, distance time graph, where we are getting a straight line that is at some slope to time axis, then we will say that motion of the object is uniform motion. Uniform motion.